A very good morning to all. Today we will discuss about the unit number 3, quantum mechanics, chapter 3, lecture 3, explanation of wave nature of particle, de Broglie hypothesis for matter waves. What is a de Broglie concept of dual natures? The universe is made up of radiation and matters. The light exhibits the dual nature. It can behave as a both as a wave and as a particles. Due to the wave nature, light occurs in interference, diffraction, etc. The particle nature is clearly explained last session: Compton effect, photoelectric effect, Planck blackbody radiations, and emission of line spectra. Since the nature loves symmetry, in 1924, Louis de Broglie suggested that an electron or any other material particle must exhibit wave-like properties in addition to particle nature. The waves associated with the material particle are called metawaves. The de Broglie wavelength. All subatomic particles exhibit the wave-particle duality, particle nature and wave natures. Here, let us consider an atom. Atom consists of nucleus and electrons. Electron orbit set of the standing waves. This is a quantum number n equal to 1, n equal to 2, and n equal to 3. Generally, the de Broglie wavelength can be written as h by p. P is equal to mv, therefore h by mv. Now we will discuss about some de Broglie wavelength. What is a de Broglie wavelength? Several minutes. The de Broglie wavelength from the theory of the light, considering a photon as a particle. From the theory of light, considering photon as a particle, the total energy of photon is given by the total energy of photon is given by here photon as a particles. Therefore, we are using the equation is a E equal to mc square. That is a photon as a particles. That is a m is a mass of the particles and c is a velocity of the light. Now, considering it is a photon as particle. Photon as particle. Now we will consider photon as a wave. That is a E equal to h nu. H is a Planck constant, nu is a frequency of the photon. Now this is equation number 1 and this is equation number 2. Now from equation 1 and 2 is a compare. Therefore, h nu is equal to emc square. It's a equation number 3. The equation 3 can be written as h nu is equal to mc into c. Generally, we know P is equal to mv or P is equal to mc. V is a velocity of the light. C also is a velocity. That is a V equal to C. Therefore, equation 4 can be written as. Therefore, equation 4 can be written as h nu is equal to Pc. It's a equation number 5. See, now we will consider this equation, that is a, we know the momentum, that is a P is equal to, we know the momentum P is equal to mc. Therefore, this equation you know very well, therefore h nu is equal to Pc. Therefore, this equations, that is a P is equal to momentum is a mc, therefore h nu is equal to Pc. Therefore, it's a equation number, we are using this equation is a S5. This is a equation number 5. Now, this equations, that is a modified, there's a rearrange. P is equal to h nu by c. This is a momentum of photon, h nu by c. Now, we know very well that is a wavelength can be written as lambda is equal to c by nu. Therefore, 1 by lambda is equal to nu by c. Okay, this value substitute in equation number 3. Therefore, P is equal to h by lambda. Therefore, the de Broglie wave, that is a P is equal to h by lambda. It's equation number 7. The de Broglie suggested equation 5 can be applied both photon and material particle. Okay, equation 7, okay, can be applied both for photons and material particles. Now, you know very well this equations. Momentum, that is a material particle, m is a mass of the particle and v is a velocity of the light. Therefore, you know very well, therefore p is equal to mv. Therefore, this equation 7 can be written as, you know very well, there is a lambda is equal to h by p is equal to mv. This is a de Broglie wavelength. Equation number 8 is a de Broglie, dB stands for de Broglie wavelength is equal to h by mv. Now we will discuss about the de Broglie wavelength in terms of the energy, other form of the de Broglie wavelength. Now we will discuss the other form of the de Broglie wavelength. Other forms of de Broglie wavelength. What is the other form of the de Broglie wavelength? For example, first of all, we will discuss about the in terms of energy. In terms of energy, in terms of voltage, in terms of temperature, in terms of temperature. Now we will discuss the one by one. In terms of energy. The de Broglie wavelength in terms of the energy. Generally, you know very well the kinetic energy. In terms of the energy, de Broglie wavelength. Generally, we know kinetic energy of the particle of mv square. Okay, now these equations, that is E is equal to, we are using kinetic energy, therefore E is equal to 1 by 2 mv square. It's equation number 1. Now this equation, yeah, equation number 1. multiplying by m both sides. Therefore, EM equal to 1 by 2 m into mv square. Therefore, EM is equal to 1 by 2 m square v square. Therefore, this equation we will arrange 2 EM equal to m square v square. This 2 come this side, and therefore mv is equal to root of 2 EM. We know de Broglie wavelength lambda is equal to h by mv. Therefore, it's a equation number 2. Substitute in equation number 3. Substitute equation 2 into equation number 3. Therefore, de Broglie wavelength in terms of energy h by root of 2 EM. It's a equation number 4. Now we will discuss about the de Broglie wavelength in terms of the voltage. In terms of voltage. Generally, you know very well, the charged particle to change the charged particle of charge say E is accelerated through the potential V. Therefore, the kinetic energy also, therefore, we are using the kinetic energy, therefore, E is equal to 1 by 2 mv square. Generally, you know very well, the energy is expressed in terms of electron volt. Therefore, E is equal to EV. See, energy is expressed in terms of the electron volt. Therefore, that is a compare the equation 1 and 2. Therefore, 1 by 2 mv square is equal to electron volt. Therefore, this equation multiplied by m both sides. Equation 3 multiplying by m both sides. Therefore, 1 by 2 m into mv square is equal to mev. Therefore, m square v square is equal to, that is a 2 from this side, that is a arranging 2 mev. Therefore, mv is equal to root of 2 mev. It's a equation number 3. We know de Broglie wavelength lambda dB equal to h by mv is a equation number 4. Therefore, the equation 3 substitute in equation number 4. Therefore, de Broglie wavelength lambda b is equal to de Broglie wavelength in terms of the voltage h divided by root of 2 mev. V is a capital electron volt. This is a equation number 5. Last one, we will discuss the in terms of temperature. De Broglie wavelength in terms of temperature. Generally, you know very well the temperature. There, when a particle like a neutron, particle is a neutron, is a chargeless in thermal equilibrium at temperature T, they possess Maxwell distributions velocity. Therefore, we are using the kinetic energy. Generally, you know very well 1 by 2 of mv square. Generally, you know very well the root mean square velocity of the particles. Generally, the root mean square the velocity of the particles. Therefore, the energy, that is a temperature, that is a 3 by 2 ABT. Okay, that is the energy at temperature, that is equal to 2. Let's compare this equation 1 and 2. 1 by 2 mv square is equal to 3 by 2 ABT. 2 is a cancel. Therefore, mv square divided by 3 ABT. Now, it's a equation number 3. Equation number 3 multiplying by m both sides. Therefore, m into mv square is equal to 3m kBT. It's a equation number 4. Now this equation is rearranging. M square V square is equal to 3m kBT. Therefore, mv is equal to root of 3m kBT. So we know the de Broglie wavelength lambda, dB is equal to de Broglie wavelength h by mv. Equation number 5, substitute in equation number 6. Now, therefore, now lambda b is equal to h by root of 3 kBT. It's equation number 7. The equation number 7 is known as de Broglie wavelength in terms of the temperature. Now the conclusion. What is the de Broglie wavelength? Lambda de Broglie wavelength is equal to h by mv. It's equation number 1. Next, in terms of the de Broglie wavelength. Next, in terms of de Broglie wavelength in terms of energy. That is a lambda dB equal to h by, we are using in terms of energy is a 2em root of this equation, root of lambda b is equal to h divided by root of 2em. Root of 2em. Next, same de Broglie wavelength in terms of voltage. Lambda dB equal to h by, we are using these equations. 2mev, there is a in terms. Root of 2me capital V. Next, last one, de Broglie wavelength in terms of temperature. Temperature lambda dB equal to h by 3 kBT. M is missing, 3m kBT. So clearly I will write h divided by root of 3m kBT. This is the de Broglie wavelength in terms of energy, in terms of voltage, and in terms of temperature. Thank you.